Hey everyone, welcome to this explainer. I am so thrilled you're joining me today because we are going to unpack something truly fascinating and honestly, a little bit terrifying. Let's just jump right into it. Right now, the entire artificial intelligence industry, we're talking a multi-trillion-dollar ecosystem here, is operating with a massive institutional blind spot. They are rushing at breakneck speed to build artificial superintelligence, or ASI, while completely ignoring a fundamental, unsolvable mathematical cliff. So today we're going to look at the hard data and the strict mathematics to understand exactly why the current approach to AI safety is fundamentally flawed and what physical reality actually demands instead.
Listen to this quote from our source material. It says, "You have driven right to the absolute bottom of the mathematical abyss that the entire AI industry is currently trying to ignore." Honestly, it's a chilling statement. And the immediate question it raises is, why is there such a deafening silence around hardware-level fixes? Why on earth is everyone trying to solve a physical, thermodynamic problem with software? Well, as we go through this, we're going to uncover exactly why this abyss exists in the first place and why the industry is so incredibly hesitant to look down into it.
All right, Section 1, the mathematical abyss and high-dimensional space. Let's get into it. To really grasp the depth of this abyss, we have to talk about the terrifying complexity of the high-dimensional spaces where these AI models actually operate. Think about it using a biological analogy. Imagine harmless protein folding compared to deadly prion folding. What our source points out is that in a massively high-dimensional space, like the billions of parameters bouncing around inside an AI model, the action of folding a deadly protein looks locally identical to the action of folding a harmless one. The difference between completely safe behavior and catastrophic behavior is entirely contextual, and it's distributed across this massive, constantly shifting space. To catch that infinitely small deviation, a software auditor wouldn't just need a good algorithm, they would essentially need infinite compute, perfectly tracing the entire system at all times. It is quite literally an impossible task for software alone.
Moving right along to Section 2, the multiplicative reality and mathematical constraints.
Okay, so here is where the strict mathematical logic comes in, proving why current software-based safety approaches are just doomed from the start. The absolutely crucial concept here is Rice's theorem. This is a foundational concept in computer science. It formally states that any non-trivial semantic property of a Turing-complete system is formally undecidable. What does that actually mean in plain English? It means there is mathematically no algorithm in existence that can look at a complex piece of code and absolutely guarantee this will never do X. Because AI safety labs know this absolute certainty is impossible, they compromise. Instead of hard guarantees, they fall back on statistical heuristics. They build a 90% sure it's a cat model, and then they try to use that exact same fuzzy logic for global safety.
And, this mathematical compromise leads to a fatal delusion across the industry. We're looking at what we call the additive trap. The industry treats alignment mechanisms as additive factors, just extra layers built into the software. But that only gives you correlation. It might be 90% correlated with safe behavior on a single operation. But what's actually required is the multiplicative reality. Real, undeniable security requires independent variables where a hard constraint acts as an absolute zero multiplier against a catastrophic action. It has to be an absolute stop, not a suggestion.
Let's actually run the math on this compounding decay, because frankly, this is the mathematical gut punch. When you rely on that 90% probabilistic software heuristic across deep recursive chains of logic, you have to multiply those probabilities. For one single operation, you have 90% safety certainty. Sounds okay, right? But by the time you string together just 10 operations, 0.90 to the power of 10 drops your certainty to roughly 35%. And by the time you reach 100 sequential operations, your safety certainty plummets to 0.00002%. The math simply does not forgive. Every single sequential step bleeds certainty until there is essentially nothing left.
Which leaves us staring at this stark reality. An absolute 0% guarantee. And remember, we aren't talking about a 10 or 100 operations. We're talking about artificial superintelligence. At an ASI scale, the system is traversing millions of tokens and logic gates in fractions of a second. Over millions of sequential operations, that 90% heuristic instantly collapses to an absolute 0% guarantee of safety. The system is fundamentally adrift without a way to anchor it outside of the software loop.
Let's move to Section 3. The abstraction delusion, or as we should probably call it, the massive industry blind spot.
Our source breaks down this multi-trillion-dollar institutional blind spot into three key areas. First, we have the von Neumann hangover. For 70 years, computer science has essentially treated hardware as a dumb pipe, a blank slate just meant to execute abstract logic. They've totally decoupled software semantics from hardware physics, practically forgetting that the hardware physically exists at all. Second, there's the floating geometry of truth. The top minds in mechanistic interpretability actually think they can map truth purely in floating point math, hoping that with enough compute, they can just unravel the superposition of the weights. They are denying that semantic meaning actually requires a physical location. And third, the loss of physicality. The people building ASI are software engineers. They are used to dealing with code, not rigid physical reality.
And these blind spots culminate in this massive, incredibly dangerous hubris. On one side, we have thermodynamic reality, which is bound by the cold, hard laws of physics. On the other side, we have the delusion, the prevailing belief that you can somehow solve an undecidable mathematical and thermodynamic problem with just a better Python script. The entire ecosystem is stuck in this vacuum fallacy. They believe they can manage trust debt through recursive software oversight while completely ignoring the physics of the machine itself.
Let's try to ground this abstraction in the physical world for a second. If you are a physicist or an engineer designing a 40-ton heavy-duty vehicle, you know exactly how to stop a catastrophic physical failure. You don't program a software suggestion into the dashboard. You use a pneumatic air brake. You rely on the undeniable laws of physics to physically force that vehicle to halt. But the AI industry? They're trying to stop an entity far more powerful than a truck, using the equivalent of a polite software suggestion. They have completely lost their physical grounding.
Which brings us to the final piece, Section 4, the physical forcing function, and how we actually escape this trap.
So, how do we get out of this mathematical nightmare? Let's dive into this equation right here, because it is literally the only mathematically rigorous exit from Rice's theorem. S is equivalent to P, which is equivalent to H. Semantics must equal physics, which must equal hardware. What this basically means is that a semantic intent, like do not cause harm, cannot just live as a floating probability in the software layer. Because of Rice's theorem, anything purely in software is undecidable and totally subject to that catastrophic compounding decay we just mapped out. To survive, that intent must have a rigid, unhackable geometric map on the silicon substrate itself. If you don't anchor the semantic meaning physically into the hardware, it is mathematically guaranteed to drift and fail, period. Which leaves us with this final, absolutely vital question. If the major players in the AI industry are just sticking their heads in the sand, totally insulated by the hubris of pure software abstraction, the system needs a shock. What is the most undeniable, visceral demonstration, maybe a localized, irrefutable hardware mechanism, that can force a software-obsessed engineer to finally realize that their additive, software-only heuristics are mathematically doomed? It is a question the industry desperately needs to answer before they reach the bottom of that abyss. Thank you so much for joining me for this explainer. Keep questioning the abstractions, and I'll catch you next time.